So far, everything we've done with trig functions, sine, cosine, tangent, and all those, has been with right triangles. So that's great, and it's awesome that right triangles can be solved so easily using those things, but it's limited. There's all sorts of triangles that aren't right triangles, that do not have a right angle. And so in that case, we have something called the law of sines. And the law of sines merely says that there's a proportional relationship between every side and the sine of its angle. So this is what the law of sines looks like. So just to draw a random triangle, we would call this A, B, C, and this angle A, angle B, and angle C. So notice that the sides and the angles are across from one another. So angle B, straight across from it is side B. Angle A, straight across from it is side A. Angle C, straight across from it is side C. So that's one important thing you have to notice. You can't just willy-nilly decide what you want A, B, and C to be. It's got to always be what's opposite each other. I want to briefly show you how they came up with this and show you how you can actually prove this law and how they did it in the first place. So let me get a new page. We're going to draw a new triangle, and we're going to call this ABC like this. So that would be angle A, angle B, and then this will be angle C. So to find the property or the law that we just found, we're going to draw an altitude. Just means a vertical line or a perpendicular line. There we go. And by drawing this, we create two smaller triangles that are both right triangles. Now this is the height of the triangle, so I'm going to call it H. So now what we need to consider is the sines, since this is the law of sines. Okay, so sine of A, so right now, just to be clear, I'm looking just at this triangle. Sine of A is equal to the opposite side, which would be H, over the the hypotenuse, which would be B. Sine is opposite over hypotenuse, so that's H over B. Now let's consider the other triangle that we created, this one right here. For this one, sine of B equals opposite, which is H, over hypotenuse, which is A. Well, if you notice, both equations have H in them. So I'm going to solve both equations for H. So I'm going to multiply both sides by B right here, and multiply both sides by A right here. So that gives me B sine A equals H, and A sine B equals H. So then we use substitution. If both of those are equal to H, then we can set the two of them equal to each other. So we'll say B sine of A equals A sine of B. And then if I divide both sides by sine of A, I get B equals A sine of B over sine of A. And then divide both sides by sine of B, you get B equals sine B equals A over sine A. I think I said that wrong, so I'll say it again. B over sine B equals A over sine A. And you can do the same thing to get the third side, just draw a different altitude. But that's the process that you would follow. So that's how they came up with the law of sines. You're not going to have to reproduce that. You're not going to have to prove that to me or show that to me, but I wanted you to see where it came from. Now let's look at our very first example. What the law of sines allows you to do is, given just pieces of the triangle, allows you to solve the entire triangle. And what we mean by solve for the entire triangle is simply solve for all of its angles and all of its sides. So this scenario would be called the angle side scenario, because that's what we have. We have an angle, we have an angle, and we have a side. and the side's not in between the two angles. That's why we call it angle, angle, side instead of angle, side, angle. So this would be angle, angle, side. And that's important for something we're going to do later. So this is angle, angle, side. So let's just set up what we have right now. We don't know A, so I'll just put A on top. But we do know the angle A is 46 degrees. We don't know side B or angle B. We do know side C is 56 and angle C is 63 degrees. So our goal here is to figure out all the sides and all the angles. What I would recommend is first in this scenario is solve for this third angle, because we know that all triangles have a total of 180 degrees. So we do 180 equals 46 degrees plus 63 degrees plus angle B. So if we add those together and subtract from 180, we're going to find that B is equal to 71 degrees. So we haven't even had to use the law of sines yet. We get 71 degrees. Okay, so we've got everything we've been able to get without using the law of sines. Now, what's really important with the law of sines is you want to make sure you start with one fraction where everything is already solved for. And what I mean is one like this right here. This is the only fraction where we know both the side, 56, and the angle, 63. So we want to start with that one. And from there, it's up to you whether you want to solve for A or B. Does not matter. We'll solve for A first because, hey, A comes before B in the alphabet, right? So I'm just going to set up the equation. 56 over sine of 63 is equal to A over sine of 46. From there, it's a simple matter of cross multiplying. So I get 56 times sine of 46 degrees equals A times sine of 63 degrees. And then to get A by itself, I divide by sine of 63 degrees. So now we can plug this in our calculator. So let's pull up the calculator. Make sure you are in degree mode. So we'll double check right here. Okay, my calculator is already in degree mode, so we're good. So we need to plug in 56 times sine of 46, make sure you close the parenthesis, divided by sine of 63 degrees. Hit enter, and we find out that it's 45.21. And we'll just go to 2 decimal places for these, so A equals 45.21. So we're down to just needing one side, because we've solved for everything except side B. Okay, so now it's up to you. You could put over here, you could put 45.21, and you could actually use these two as your next equation if you wanted to, because now you do know both side A and angle A. But I would recommend sticking with our first one. I would recommend still doing these two. And the reason for that is we just rounded A, so we're not using the exact number. So it's better to use the one we started with because we're using exact numbers. So we set up that equation. Excuse me. We'll go ahead and cross multiply. So we get B times sine of 63 equals 56 times sine of 71. Then to get B by itself, we divide both sides by sine of 63 degrees. So now we know B equals 56 divided by, 56 times sine of 71 divided by sine of 63. So we will move this over so we can see and do 56 times sine of 71, close the parentheses, divided by sine of 63. So we get 59.43 for side B. And we have solved for the entire triangle. So that's how to solve it using angle, angle, side.